Okay, general curve sketching. Open intervals where function is increasing and decreasing. Well, what we know is everywhere you have an M tangent, that's where a curve will be because that's where the slope is equal to 0, right? So if you have a graph that looks like this, look at that's where the two curves are. And then once you know where the slopes are equal to 0, look at what's happening here. That interval, the graph is going up. That interval, the graph is going down. That interval, the graph is going back up again. This interval, the graph is going up. This interval, the graph is going down. All right. And then what you use is you use closed interval notation to indicate that. All right. So for this graph right here, we just have a upside down parabola. We know where it touches the y-axis. But if we want to know where this max is right here, we find the derivative. So the derivative is negative, except for I'd have to do that correctly, negative 4x plus 16. Well, we know the tangent line is equal to 0, so we set this equal to 0. I'm going to factor out a negative 4, and that leaves x subtract 4, because negative 4 times negative 4 is positive 16. So we only have one place where x is equal to 4 is where the M tangent will equal 0. No, that's not very good. So I'm going to draw the graph maybe more like this. So if this is the y-axis right here, this might be negative 30, and this that's a positive 4. The graph goes up just like that. All right, so notice, well, what I should. So this is a little bit better sketch of the situation right here. So now where are the intervals of increasing? Well, right there, that graph, as we read left to right, is going up. It's a little bit confusing because, while the arrows are going down, but if you're starting down here at infinity, to get up here to the height of 2, because if you plug 4 into here, you end up getting a height of 2, you're going up. So that means the interval of increasing is from negative infinity up to 4. All right? And then what do you have? When you're up here at the height of 2, you leave there, you're going down. So that means the interval of decreasing is 4 to positive infinity. Because remember, as that goes down, it's also increasingly going to the right. So that's why you get positive infinity. And over here, that's why you get negative infinity. All right, let's look at another one. So this is a negative x cubed, so it's going to look something like this. So we need to find where those mins and maxes are. So this is a min, this is a max. And where are those? Well, we're going to take the derivative. So dy dx, or y prime, is negative 3x squared plus 8x. Remember, the derivative is equal to 0. The tangent line is equal to 0. And I'm going to factor out a negative x because we want to bring out that negative sign, and they only share an x. So that leaves 3x minus 8. So the x on the outside of parentheses is always 0. So one of them will be 0. And one of them will be let's see, the opposite of negative 8 is positive 8. The inverse of multiplying 3. So that means this right here, this will be the x-axis. So where x is equal to 0 and where x is equal to 8/3, those will be our mins and maxes, just like that, where the slope of the tangent line is equal to 0. And now we have to find our, so I'm going to do the decreasing in blue. Those two areas are decreasing. Well, what are those intervals? Well, this interval is all the way up to 0. So from negative infinity to 0, we have a decreasing graph. And we're starting here, then from 8/3 to positive infinity, we have a decreasing. And then the only thing that's left is right here. That's increasing. So from 0 to 8/3, this graph, that's an interval of increasing. Let's see. So an x, positive x to the fourth. So we're going to have decreasing there, decreasing there. We're going to have increasing there, increasing there. So y prime, so 4x cubed minus 2x. We're going to set this equal to 0. We're going to factor out what they have in common. They have a 2 in common, and they have an x in common. And that leaves 2x squared minus 1. All right? Well, again, x on the outside is always equal to 0. But inside here, what do we have? So I'm going to set this whole thing equal to 0. I'm going to add 1. Now 2x squared is equal to 1. Divide by 2. So now I have x squared is equal to 1/2. When you take the square root of both sides, remember, when you're dealing with a quadratic, you take both the positive and negative. The square root of 1 is 1. Ooh, we can't take the square root of 2, so we're going to have to multiply top and bottom. So square root of 2 times the square root of 2 is 2. So x is equal to both negative root 2 over 2 and positive root 2 over 2. And just plug those into the calculator, but those will be our interval amounts. So negative root 2 over 2, and then 0, and then positive root 2 over 2. Those are our intervals. So let's see. We've got this interval. Well, that interval is decreasing. So from negative infinity up to negative root 2 over 2, decreasing. The next interval is increasing. So that means this interval, let's put it this way. This is negative root 2 over 2. This is 0. This is root 2 over 2. So from negative root 2 over 2 to 0, we have increasing. And then we have another decreasing. So from 0 to positive root 2 over 2, we have decreasing. Oops, right here, decreasing. And then finally, the last interval, we're back to increasing. So from root 2 over 2 to positive infinity, we're increasing. All right, that's it for this one.